Hello students, the question says an object of mass 500 grams initially at rest is acted upon by a variable force whose x component varies with x in the manner as shown. The velocities of the object at the points x equal to 8 and x equal to 12 would have the respective values of. So, okay, as you can see, he has given a force versus displacement graph. So, force versus displacement graph is given. And not only that, he has given mass of the body as 500 grams. So we can take it as half kg. And initially at rest, so initial velocity is 0. We need velocity of the body at x equal to 8. So we want velocity at this point at x equal to 8 and x equal to 12. To solve this problem, we use work energy theorem. We simply write work done by a force equals to change in kinetic energy. Because there is no potential energy here, there is no non-conservative force here. So the only thing is work done by a force equals to change in kinetic energy, that is K final minus K initial. And since K initial is 0, we can directly write whatever is the work done we get, it is equal to K final. Now, we need to find initially the velocity of the body at x equal to 8. So we have to find the body at x equal to 8. So to do that, work done is simply area under force versus displacement graph. Now let us try to find the area under the force versus displacement graph. From the graph, we can see clearly that this part is a rectangle and this is another rectangle. So let us try to find work done is equals to A1 plus A2. So area is base into height. This is, I think, 5. This is 0. So this length would become 5 minus 0. So it would become 5. And this height would become 20 minus 0. So it would be 20. So A1 would be 20 into 5 plus A2 would be, this is 5, this is 8. So 8 minus 5. 8 minus 5 would be 3. And this height is 10 minus 0. So I think it would be 10. So 3 into 10, 30. So we will get this as 100 plus 30, 130. And we know work done is equals to half mv square. Work done equals to half m into v final square. Why? Because there is no initial kinetic energy. We can write this as half m into v square. That's what we need to find, as u is 0. Half m into v square equals to 130. So v is root of 130 into 2 divided by 1 by 2. So it would be root 130 into 4. So since we want root 130 into 4, we know 11 11s are 121. So 2 into 11 11s 121. So approximately 11 point something. So we can write this as 22 point something. So 22 point something means the first option would be either 23 meter per second. But we have two options with 23 meter per second. Option C is 23 meter per second. Option D also is 23 meter per second. Now, once we know that, let us try to find the next one. To find the next one, we can directly do it. We can use logic to solve the problem. As you can see, here we have negative area. And you can see the extra positive area is much lesser than the extra negative area. Since it is much lesser than the negative area removes the energy from the system. Since the negative area is much more than the positive area that got added, we can say the final velocity would be lesser than 22. The only option where final velocity is lesser than 22 is this one. Because this would be, if you solve it exactly, you might get 23 meter per second. And for the second case, the answer has to be lesser than 23 meter per second. And the only option where the answer is lesser than 23 meter per second is option D. You can directly mark option D. But let us try to solve it, whether it is lesser than 23 meter per second or not. So to do that, so let us go for it. we get this new area as, let us break it down into a rectangle and then a small triangle. So this would be total work done is, already we have our 130. So this is extra thing that we get 130 plus this rectangle would be, base is 8, 10 minus 8. So it would be 2 into height is, this is 0 and this is 20. So we have to find this height. So to look at the height, we have to look at the y coordinate. To look at the base, we have to look at the x coordinate. In y coordinate, we can see clearly it is minus 20. Then plus half, we have this one also, half base into height. Base is again 2 into height is minus 5. So this is one more thing. And the last one is the positive area that got contributed. It's a rectangle. So base is 2 into height is 10. So let me just write them, 130 minus 40 minus 5 plus 20. So it would become 150 minus 45. So it would become 105. We get the value as 105 joule. We equate it to half mv square equals to 105. So we will get new velocity is, we know this is 1 by 2. So root 105 into 4. So if I solve the value of root 105 into 4, so let me just do it, 105 into 4 would give you 20.5 meter per second. I will do this exactly with a calculator and see what's the value we are getting. 130 into 4 would give me 22.8 meter per second. So approximately 23 meter per second. So we can say this value would be 20.6 and this value would be 23 meter per second. But as I told you, you no need to solve this to tell the value would be 20.5 meter per second. We know the negative area is much greater than the positive area. So the final value at x equals to 12 would be lesser than the previous result. The lesser than previous result would be 23 meter per second. But I hope you understood the method. Thank you.